Alright students, so this question is again from NCERT Exemplar. Chapter is Gravitation and the question number is 8.8 NCERT Exemplar. Why I picked this question is something you need to hear. Now first, the question is in itself not very difficult to solve, but the choices are definitely something worthy of being discussed. We must understand the choices also to develop our concept. One concept development is we are able to solve the question, get the correct answer. Answer is A. But what about B, C, D? Is there any learning from B, C, D is also very important. I found this question of gravitation to have those learnings inside it, which will help you develop further deep knowledge in the area of gravitation. Right? Let's discuss the question. All right. So you have a situation in which there is a mass 2m at A, and then there is a mass m at C, and there is a very small mass. Obviously, small mass means a test mass. Like even electrostatics, there's test charge. So a test mass, okay? Negligible mass. It is kept at B. Now the problem is, it says, everything is at rest. When we start the experiment, we keep the masses, everything is at rest. Now the question says, before the collision, what is going to happen, right? Choice number A, M will not move. Second, M will move towards M. M will move towards 2M, or will M have oscillatory motion? So first of all, what is the context of the word collision? Obviously, I think they mean that the body, the test mass will move either here or there and will collide. So we are supposed to discuss what happens before the collision, or maybe the M mass is at rest. If you notice this, you can see that the test mass will be subjected to two forces, right? So the two forces are going to be the force applied by A on B, right? So which is going to be 2m upon, so let's say this particular distance is r1, right? So this is going to be r1 square. The force being experienced by B due to C, right? So this is FCB is equal to going to be m into m upon r2 square, assuming this distance is r2, right? Of course, gravitational constant is going to be there. Now, if you notice this particular distance r1, right? R1 is much smaller than R2. If R1 is very small and the mass of this M is twice 2m as compared to the one at C, right? You can see the situations. So this particular mass at A, it is heavier and this is closer. So you are 2m and you're closer also. What happens? This expression becomes very large, right? Because you're double the mass, the force is proportional to mass, you're double, and then your distance is also very small. So you're inversely proportional, right? So straightforward, right? So which means the mass m will move towards 2, it will get attracted towards 2m because the force of pull which is coming from 2m is much large because its mass is very large and the distance is very small. We have seen the mathematics of this, but okay, so we have solved the question, right? So the answer is the mass m will move towards 2m. Answer done, right? But no, I want to bring your attention to the other choices which we need to discuss because that is where you will start learning. Don't ignore the other choices. Also understand what's so special about these choices and how can we analyze them to arrive at some conclusions. Let's discuss. Okay, talk about the first one. M will remain at rest. Obviously, we found that this side the force is attractive force is more as compared to the other side, and therefore the body will move towards 2m. Done. But can there be a situation where this m is at rest? Equilibrium. The body is in equilibrium. The forces which are coming from both the sides is now getting balanced. So assume the equilibrium is somewhere here. Let's say the equilibrium is here. So this distance overall is d, this distance is x, and this particular distance is d minus x, right? The mass m is at rest. So what I'm telling you that here you have equilibrium. Let's write this, right? So what is the force being experienced by m due to 2m? It is equal to 2m multiplied by m divided by d minus x whole square into g. This is the first force which is being experienced by m due to A, right? So this is due to A. the force which is experienced by the test mass due to C is given by m multiplied by m upon x square into g. Now because the body is in equilibrium, the force due to A and the force due to C are equal. The body is experiencing equal force from both the directions, and therefore if we write them to be equal to mm upon d minus x whole square is equal to, g gets cancelled from both the sides, so this is mm upon x square, right? So all this gets cancelled, you are left with 2. So under root of 2 divided by d minus x is equal to 1 upon x. So root 2x is equal to d minus x. If I take x on the other side, this becomes root 2x plus x is equal to d, and therefore d is equal to root 2 plus 1 and x is equal to d upon root 2. Point of equilibrium. So we were able to find a point where the body is going to be at rest. So this test mass, if it is kept like this at a distance x from C, this is the distance from C, to keep it like this, you will be able to get where the test mass is at rest, right? That is why this was very important, right? Now let's move forward to the other choices, okay? This choice is wrong, right? So we don't need to worry about it because the body moved towards 2n. So B is wrong. This anyway was right. Let's discuss the D part also. M will have oscillatory motion. Now, what is the stage? We have kept the body at the point of equilibrium. The body now is experiencing force from both the sides. It's in equilibrium, right? Why I tell you, this current situation is very, very important. And here is why. Let's discuss. I will just rub this off. Okay, and what we will discuss now is the oscillatory motion of this particular test mass. Okay, let's discuss. All right, so now what happens? Okay, the test mass is, I will redraw this so that we are in complete know of what we're doing. So this is your situation. Sorry, I think the color is all right. This is your situation, and now your test mass is located here, right? This is m and this is 2m, right? And we know x is equal to d upon root 2 plus just this. Here you are getting equilibrium. Now for oscillatory motion, what is required? One word for an oscillatory motion, what is required? So if you see NEET 2025 paper, there is an electrostatic question in which there are charge which is kept somewhere, and it, they ask you about SHN. Very similar. Which two big masses, one test mass, equilibrium condition. What is the main condition for oscillatory motion to happen? All right. So the correct word is stable equilibrium. If this body is in stable equilibrium, you will get oscillation. What is stable equilibrium? If you move this body towards this side, there is a restoring force on it. Someone calls it back. If you move it on this side, it has a restoring force. It wants to come back to the original position. But do we have stable equilibrium in this particular situation or not is the question. Let's test it. I'm saying there is unstable equilibrium, but let's test it. Now, if I move this body a bit here, what happens? This particular distance gets disturbed. This mass will attract it, because now its force will become bigger than this, the force applied by m, because now your x has become greater than this. So you have moved farther from the smaller mass and you have disturbed the equilibrium, and you have done this in a manner, the moment you move towards 2m will just snatch it away towards it, right? Because now its force has become bigger than the force which is exerted by small m. It's an unstable equilibrium. There is no one to bring this small test mass back. Just one force dominates the other. The dominating force of 2m dominating force just pulls the small mass towards it. There is no restoration. So no oscillatory motion is possible between two masses, even if you have a equilibrium condition, because that equilibrium condition is different in nature. It's not stable. It's an unstable equilibrium. On my channel, you have 3,000 plus videos, 2,000 practice questions. I also run a blog. You can check out my blog also, which is given on the channel, where the notes are available free of cost. Occasionally, I put questions on physics, chemistry, biology, which you can check, and they are very innovative. You will not find those questions anywhere. They're not copied from anywhere. So please do watch my channel, like, subscribe, put your comments below if you like it. And if you have any doubt also, please put it. Thank you very much for watching my channel and look forward to next video.